Today, I am talking about different types of next generation batteries. It is more important than ever to develop effective and environmentally acceptable battery technology as the globe shifts to renewable energy sources. We will be discussing solid state, lithium air, redox flow, and biobatteries. First up, solid state batteries. Instead of the typical liquid or gel polymer electrolytes found in conventional batteries, these batteries use solid electrolyte. They can overcome various challenges faced by liquid electrolyte batteries such as flammability, limited voltage, and strength. Up next, lithium ion batteries. By using oxygen as an electrolyte, these novel batteries can theoretically lead to electrochemical cells with the highest possible specific energy. Due to the gaseous electrolyte, they are extremely light. Next, we have redox flow batteries. These batteries store energy in liquid electrolytes held in large external tanks. This makes them scalable and perfect for grid energy storage. With a long lifespan and easy recyclability, they are ideal for large scale energy storage systems. Finally, biobatteries. These produce energy by using organic compounds like sugar or bacterial cultures. Although biobatteries are still not up for commercial sale, research is ongoing. There are potential applications for biobattery in the medical field. So, what's the best option out there? Solid state batteries are distinguished by the energy density and safety, and redox flow batteries excel in large scale energy storage. While each has advantages, solid state batteries and redox flow seem to be the most practical option and have the most research behind them, although this could change in the future. In conclusion, advancements in battery technology are critical as we work towards a sustainable future. Particularly, solid state batteries hold potential for realizing our aspirations for renewable energy. The prospects for eco friendly energy storage are virtually limitless as we embark on this path. Thank you.
Good morning. I'm Ritika Ritesh, grade 7B, Pearl Wisdom School. Today, I'm going to be conducting an experiment using red cabbage to test pH for week 1 of Qutuhal. So firstly, let me explain why red cabbage is such a great natural pH indicator. It is because it contains anthocyanins, pigments that change color based on acidity or alkalinity of a solution. Anthocyanins react to pH by gaining or losing hydrogen ions, causing the color shift. It is a natural, safe, and simple way to test pH. So here we have red cabbage solution that has been diluted with water so that we can see the color change much more clearly. So to obtain this, we had to chop up half of a red cabbage, pour boiling hot water on it, and then wait for about 20 minutes, then strain it to obtain the solution. So what we're going to do is here we have 6 cups, and then we're going to add the red cabbage solution onto these 6 cups, and then add different solutions and substances that have varying pHs to see the color change. Let's do that, shall we? Now that we've filled these 7 glasses with the red cabbage solution, we shall be adding our different solutions with substances that have varying pHs to test the color change. So, before we start the experiment, you should know that if the substance is acidic, it will turn a different shade of red or pink, and if it's neutral, it shall stay purple itself. And if the substance is basic, it shall turn blue, green, or yellow, depending on how basic the substance is. So, firstly, here we have a lemon, which has about a pH of 2. So, let's just add it. Let's drop the lemon juice onto the solution. Be sure to not let the, as you can see, it has turned like a bright pink color, meaning that the solution is acidic. So next we have orange juice. So let's try adding that. It has a pH of about 3 to 4. It has turned more of a peachish color, but it's still acidic. And next we have milk. Milk has about 6.5 to 7 of a pH, so mostly neutral, but let's just test it. As you can see, there's not much color change. It's just staying purple. So that means it's about neutral. And here we have water. Water, as you know, is very neutral, so there won't be any color change. It's just turning lighter, diluting the solution. So next, we're moving on to basic substances. So here we have a solution of toothpaste mixed with water. So let's try adding that. It's turning more of like a darker purple, indicating that it's more of a bluish purple, so indicating that the solution is basic. So next we have dish soap. This might need a bit of a stir, so we've added a good amount. Let's just take a spoon and try stirring that. It instantly turns green. That indicates that the solution is basic. Next, we have one of the most basic household items there is, and that is Clorox, and be careful when you're using this. So we just add that, and it has turned yellow. So, as you can see, all of these substances have turned into about a rainbow of colors, and from the lemon juice till the milk is acidic and the water is neutral, and from the toothpaste solution to the Clorox, it's basic. So this proves that different substances have different meanings, pHs, and it can be tested with a red cabbage. Thank you.
Hello everyone, my name is Krishna Karthikeyan, studying in 8F. This is my submission for Qutuhal Week 1. What are the three main states of matter? Solid, liquid, and gas. But there's another one, plasma. It is the hottest and most volatile state of matter, and this is a plasma globe. The first plasma ball was invented by Nikola Tesla in 1894. The design called electric light source looked like a lamp with a glass bulb and one electrode. But how does a plasma globe actually work? The electrode at the center of the plasma ball emits a high frequency, high voltage alternating electric current. This current flows through the plasma filaments to create colorful tendrils of light that you can see here. The color depends upon the gases used inside the plasma ball. So they can be all different shades: blue, green, and here reddish pink. Common gases that are used in the plasma globe are neon, argon, xenon, and sometimes even krypton. Why does a plasma ball follow a finger? These fronds of plasma make their way from the center of the globe to the edge in a bid to reach the earth. Creating an enhanced path to the earth by touching the globe increases the strength of the discharge, which is why the arcs are attracted to your hand if you touch the globe. Is it safe to touch a plasma globe? It is quite common for people wearing rings to accidentally touch the orb before removing them, thus resulting in a small shock. As the electric current within the plasma ball produces a small amount of electric interference, which can produce a lot of heat. It is important to avoid close contact for anyone who has a pacemaker. Let's say I can keep my hand here for a few minutes. After a few minutes, the heat will be produced and the area where my hand is placed will feel much more warmer. Also, it can change the polarity of many objects. That is why I've kept a coin here. If I put my finger on top, a small spark is being created. This is an internal spark that's produced here, but once the polarity changes, an external spark will also be produced, which will not hurt. So, is it safe to keep a plasma globe on most of the time? Usually, no, because some of the gases can escape and cause electrical accidents. So, in summary, a plasma globe is one of the amazing things created by scientists, and it is such a wonderful creation. Thank you so much.
Everyone, my name is Havish. I'm studying in 7th standard at GIS Smart Campus, Singapore. Today, I'm going to explain how to make a simple electromagnet at home. But what is an electromagnet? How is it different from a permanent magnet or magnets that we normally see? Where are these used? How a simple electromagnet can be made at home and a few interesting facts about them. An electromagnet is a simple magnet that can create a magnetic field by using a simple electric source like a battery. This magnet attracts and magnetizes ferromagnetic materials like iron, nickel, and cobalt. A simple basic electromagnet can be easily constructed at home using common household components like battery, copper wire, paper clips, iron nails, safety pins, coins, etc. This is a simple procedure. Just wind a copper wire to an iron nail, connect its ends to the battery, hold on for a while till it magnetizes and tries to attract items like iron nails, screws, knives, safety pins, etc. Observe how each item attracts or repels by the simple electromagnet.
These are the materials that I'm going to use to make a simple electromagnet. Now let's move on to step 1. So step 1, we have to wind this copper wire around this miniature screwdriver. Not too close and not too far. Leave the endings a bit longer. I'm going to attach these two ends of the wire to a battery and wait for a while. My tape. Now, as you have seen, I've connected the battery, but it's not magnetizing anything. Let's wait for a while so it can get magnetized. Let's try. As you have just seen, it held on to the magnet for a few seconds, but the magnetic field is not strong enough. Now, as you can see, it is attracting different materials differently, iron and steel. See, the screw is getting attracted by this electromagnet. Now let's try the paper clips. It does not seem to be attracting it. This paper clip has gotten attracted but has fallen down. Now it is getting fully attracted. Now let's try a spring. The spring does not seem to be getting attracted. So it is made up of steel. Now let's try this. This one is also made of steel. Now let's try the coins. The coins are also made up of steel. Now lastly, let us try the spoon. The spoon is also made up of steel. So the only one things made up of iron are the screws. And the rest of them are steel.
Now we saw how a simple electromagnet can be made at home using simple things. These electromagnets are used in many of our day-to-day devices like electric doorbells, locks, loudspeakers, and yes, even in our earphones. Also, they are used in electric motors, generators, transformers, magnetic recording devices, and MRI machines too. These interesting facts about electromagnet its main advantage over a permanent magnet is that the magnetic field can be quickly changed by controlling the electric current in the winding. In the demo I have shown earlier, the battery can be changed to a higher voltage and lower voltage to observe the change in the magnetic field. The strength and versatility of these electromagnets make them indispensable in many fields including engineering and medicine. Hope you like my presentation. Thank you.
All, let's perform a simple experiment to learn about the density of liquid and buoyancy of objects. Materials required to perform this experiment are honey, water with a bit of food color, oil, nut, bottle cap, and sponge. Let's pour some honey first. Now let's pour water and at last we will pour oil. What do you think will happen? Each liquid has different density and hence forms layers. Now let's test the buoyancy of object. Let's drop the nut, then the bottle cap and the sponge. As you can see, the nut sinks and the sponge floats. Hence, we can conclude the formula for density. Density equals to mass upon volume. We can now understand that's why oil spills stay on surface of water.
Hello everyone, my name is Ayandas and I'm from my private school. Today I will be conducting an experiment called the lava lamp. Yes, you heard it right. I'm making the lava lamp. But don't worry, I'm not going to go to a volcano and get some lava. And we don't need science experiment tools also. We just need some simple everyday items like oil, and I've poured some vinegar in the cup, some baking soda, then we need food coloring, a light and a bottle. So let's start the experiment. First, we start by putting some baking soda in the bottle. Then we pour the oil. Now take the vinegar and then put some food coloring in. Mix the solution well. Now we'll put the solution in this. Wow! Now these bubbles are the carbon dioxide. They are less dense than oil and vinegar. Vinegar has come to the bottom with baking soda. When vinegar reacts with baking soda, it forms carbon dioxide. These carbon dioxide bubbles are going up because they are less dense than oil. Vinegar and oil are immiscible liquids. Immiscibility means that two liquids do not become a homogeneous mixture. They do not mix with each other. Thank you.
Cloud seeding is a way to help make rain by adding tiny particles to clouds. Think of clouds like big fluffy sponges in the sky that are full of water. Sometimes, even though there is water in the clouds, it doesn't rain because the water droplets are too small. To help the clouds make rain, scientists use aeroplanes to sprinkle tiny pieces of a special material, like salt or silver iodide into the clouds. These make tiny particles act like little magnets that attract the water droplets, making them bigger and heavier. When the water droplets get heavy enough, they fall from the clouds as rain. Cloud seeding can be used in places where there isn't enough rain, like dry areas, to help water crops and fill lakes. It doesn't always work, but it gives clouds a better chance of making rain. Did you just hear that? That was a hiccup. Do you know what a hiccup is? Let me tell you. When we breathe, a muscle in our body called the diaphragm helps to move the air in or out of our lungs. It's like a little helper for breathing, but sometimes the diaphragm gets a little silly. It suddenly jerks, and that makes us breathe in super fast. When this happens, the air hits our vocal cords and we make a funny sound. Just like that. You might get hiccups if you eat too fast, drink fizzy drinks, or even if you laugh a lot. They usually go after a while. So, next time you hiccup, remember, it's just your diaphragm having a bit of fun. Thank you.